Hi everyone. We are at the last problem set for the kinematics, and after watching the video on free fall, you should have the understanding that anything on the earth, no matter what it is, will always accelerate downwards at a rate of, we're going to put it right up here, acceleration due to gravity, 9.8 meters per second squared. All right, now there are slight discrepancies in that value. The higher the altitude you are, the further you're away from the center of the Earth, so the lower your acceleration is going to be, but it's so minimal, we don't look at that discrepancy. So we're always going to use this right here. So we have question 33 is what we'll start with here. It says, a stone is dropped straight down from a high cliff. What is its speed after 5 seconds of free fall? So you have time equals 5 seconds. Now, your first initial reaction might be, there's not enough information to answer this question. I only have one thing that's given to me, but that's not true. See, we know if this object is this stone is going to be dropped, that it's going to accelerate down towards the Earth at a rate of 9.8 meters per second squared. There's another thing that's interpreted here. If the stone is dropped, you're holding it at first. So if you're holding it, then you have an initial velocity of 0 meters per second. And then the last thing, they're asking you to solve for what is the final velocity. All right. So based on that information, we're going to hop over to the formula sheet, and we're going to see what formula in here has our variables. I see time, VF, acceleration, and VO. Well, on my list, I see acceleration, VF, VO, and T here. Now, yes, it's not arranged to solve for final velocity, but you could rearrange the formula, or you could just grab the one that's already pre-rearranged right here if you wrote it down on your formula sheet. So we're going to use that one. Okay, so we'll put that formula in here. We'll have VF equals VO plus A times T. And you can substitute in your variables, and your answer, what you should come up with, if you do the math right, it should come up to be 49 meter per second. All right, now you have to complete the work. You can't just put this down. You have to actually fill in the substituting information. You have number 34 now. 34, we have, suppose that a stone is thrown straight down from a high cliff. If the speed at the time of its release is 20 meters per second, so we have VO is 20 meter per second. What is the speed after 4 seconds of free fall? So we have 4 seconds. And it's asking for what the final velocity is. But there's one other piece to the puzzle that you are going to be aware of. That's the acceleration due to gravity. That's going to be the 9.8 meter per second squared. So what you have to do now is you have to look through that formula sheet and identify your equation. You'll need to substitute in your variables. And then your final answer here, what should you get if you do that correctly? You should end up with approximately 59.2 meter per second is what you should have for your answer. All right. We go to question number 35 now. We have 35 says a stone falls from rest. All right. So, well, VO is 0 if it's from rest. We have a time of 4 seconds. And it says, how far does it fall? So we have distance equals question mark. Oop, I put that in the wrong spot. We want to put that down in the unknown. We do have one other piece of information that I can put up here. That's the acceleration due to gravity. All right. Now, for this one, I'm going to help you out just a little bit. We find the variables VO, T, A, and D from my formula sheet. You grab your formula sheet, you look through the list, which one of our formulas has all 4 of those letters? Well, the one that has all 4 of those letters, I have distance is what I'm trying to solve for. I know gravity, I know time, and VO happened to be 0. So that means that the equation we're going to use to solve this will be AT squared divided by 2. Now what you need to do is fill in your substitute. You fill in your solve for this. And what you should end up with, if you did this correctly after you punch the numbers into the calculator here, you should end up with, we have, should be 78.4. So you should have 78.4 meters. I want to make sure I had that right for you. We go to 36. Our next one, we have number 36. 36 says that we have a stone that's dropped from a high tower. So I'm going to put this on here. The VO for that has to be 0 for dropping it. We know that it's going to be falling, so we can put in the acceleration due to gravity. And it says that it's going to drop from the high tower and 3 seconds later. So we know the time is going to be 3 seconds. What they're asking us to solve for is how high is the tower as it hits the ground? What's the height that it was dropped from? Well, from the information that you have here, it's very similar to the last problem. So you figure out your equation, you substitute your variables, and then you want to solve the problem. When you have that all taken care of, if you get 44.1 meters for your answer, then you did it right. Okay, and then we can move on to question 37. Number 37 is next. Number 37, while flying a plane parallel to the ground, a pilot releases a fuel tank in order to reduce the plane's mass. What is the tank's vertical velocity after falling? All right, now first, we're going to say this has to be interpreted. Vertically, when the tank is dropped, the velocity up and down, it's 0 at first because it's flying parallel to the ground. All right, now horizontally it has a velocity, but vertically it does not. The second thing is we know that the tank is going to drop at the rate of 9.8 meters per second squared. And the distances, there's 2 distances. There's one that's a 10 meter, and that's part A. And then we have part B where the distance is 100 meters. And it says, what is the tank's vertical velocity? So I'm going to put velocity. This is part A right here. We're going to have A here, and we're going to put B over here. What's the final velocity after that 100 meter drop height? All right. We need to find an equation for this. All right. So we have VO, A, D, and VF. So looking at the formula sheet now, we have to look through and find the one that has all of those variables: VO, A, D, and VF. All right, so going through process of elimination, I know that it's not these. There's no distance here, so can't use that. There's no time given to me, so it can't be that. So it must be the bottom ones. The bottom ones, VO was 0. So right here I have VO was 0. So that's got to be the equation I'm going to use. And here I have VF, A, and D, and that matches up with the variables that are given to me in the equation, or in the actual problem. So we're going to use that one. We're going to have VF equals the square root of 2AD. Now, when you go to substitute in your numbers, make sure when you type it into the calculator that you put the square root button, then parentheses, so you'll have square root, parentheses, 2 times, and then you put in your other information. But your final answer for this, for number 37, for the first one, for A, because remember, this distance here, that's going to be 10 meters. So we might as well just fill in the rest. All right, here we go. So I'll do the first one with you. So you have this right here. That's your setup for this. So your final velocity should be 14 meter per second for that. Now for part B, you're just going to take this right here and you're just going to change your number to be 100 instead of 10. Okay, so I do want you to show the work, yes. All right, I gave you that. You can fill out the work. We have number 38. Number 38, it says a stone is thrown straight down from a cliff with an initial velocity, so we have VO equals 8 meters per second. What is the stone's velocity after 3 seconds? So we have time 3 seconds. We know that gravity is going to be 9.8 meters per second squared. And it says, what is the stone's velocity after? So we need to find the final velocity here. And the other thing that it's asking us to solve for is how far down that this stone is going to be thrown. Now at this point, I'm going to expect that you can find the equation that has these 4 variables in it. We did one of those already in this problem set. You figure out your equation, you put in your substituted variables, and then your final answer for this, if we figured this value out, it should be a value of 37.4 meters per second. All right, now from that information, you do have to have that information, all right, in order to solve the second part. So you'll have to find your equation based on the variables given to you, and you will have one extra one, right? You'll have final velocity too. You'll substitute in the numbers, and then your final answer here for this should be 68.1 meters. All right, you have to be able to show how you came up with that. Number 39. Number 39, we have what is the final speed? So I'll just put that down right now. Final speed. What's the final speed of an object that starts from rest? So VO is 0. And falls freely. Well, that's gravity. For a distance of 64 meters. All right. Now the key for this one is that you have to find the formula in which VO equals 0. All right. You do that. You identify the correct equation. You substitute in your variables. And your final answer for this one should end up being 35 meters per second is what you should have for that. All right. We go to the last question here. The last question, you have number 40. Number 40. We'll get that out of the way. 40 says a mortar shell is accidentally shot straight up with an initial speed. So you have VO equals 147 meters per second. How long does it take for the acceleration due to gravity for it to reach a speed of 0? All right, so we have a final velocity here being 0 meters per second. We know gravity is 9.8 meters per second squared. And it's saying how long does it take? We need a time. All right. You have to look through. There is one equation at the very beginning of all of our stuff that has all 4 of those variables. Use that equation, right? Plug in your numbers, and then your final answer for this, I'm going to let you take and share it with me. I'm not going to give this one to you. Question B is how high does this actually get shot up? Well, now you're going to have the time in as a variable as well. So your distance, what you need to do is identify what your equation is going to be, your substitute, and then your solve. All right, that's going to take care of us. Now, if we are finished with the problem sets, we are going to do a review of the kinematic questions. That's from the homework page. All right, that's from, and I'll show you that right now so that way you know what I'm talking about. That is going to be these questions right here. All right, we are going to do those reviews, But we are coming up rapidly on a test, and you're going to need to be able to answer kinematic problems on your own. So when we do the review, you're not going to get as much help. And what you're going to have to do is identify where your weak areas are. And if there is a weak area, you need to get some help. Don't wait until the last second to get some help on how to answer these questions. I would really, really, really advise you to get your formula sheet squared away so that way you have it. Write any notes down that you need to, right? If you don't have any questions on this after it's completed, make sure your name is at the top of the paper, take pictures of each page, and then submit it to Schoology. All right? That'll be it. Take care.